Are the following functions even, odd, or neither? Alright, in order to prove whether functions are even, odd, or neither, if you will look right over here, an even function is when f of x equals f of negative x. If you substitute a negative x in for x into the function and you get the same thing, then the function is even. An odd function is when f of negative x equals negative f of x. And with that, you can just usually distribute a negative to everything to see if there's an equality here. A suggestion for doing these exercises is to find f of negative x first, because you will need to be finding it for both even and oddness of a function. So right now we're going to look at part A. We already know f of x is x to the fourth power minus 2x squared plus 3. So per the suggestion, I want to check to see what f of negative x is. And I'm going to do that in red. So f of negative x is negative x to the fourth power minus 2 times negative x squared plus 3. And when you simplify this down, you get f of negative x equals x to the fourth minus 2x squared plus 3. It looks like f of x and f of negative x will be exactly the same. So f of x is an even function. Another way you could tell that f of x is even is by looking at the exponents on the variables. If you notice, right here, there's an x to the fourth. Right here, there's an x to the second power. And over here, with the 3, there's an implied x to the 0 power. And we don't write it, just for illustrative purposes here, to show you that x to the 0 power is in that last term. All of these exponents on the variable are even. So that's just a shorter way to go through and say, hey, this function is even. Part B, we will be looking at g of x equals x cubed minus x. And again, per suggestion, I would first want to find g of negative x. So I will substitute negative x everywhere. So it will be negative x to the third power minus negative x. When you simplify this down, you will get negative x cubed. And when you subtract a negative, that turns to addition, so plus x. So g of negative x equals negative x cubed plus x. That is not what we started with up here with g of x. G of x has a positive x cubed and a negative x. So we can say These do not match. Oops. So g of x is not even. So why don't we take a look at negative g of x. So maybe we can check to see if g of x is an odd function. And remember, to do this, you just stick a negative in front of the entire function, x cubed minus x. And then we can distribute that negative to each term to see that negative g of x is the same thing as negative x cubed plus x. And you may notice that this and this are the same. And if you look at the left-hand side of both of those equations, we can say g of negative x is equal to negative g of x. So we can conclude that g of x is an odd function. Similarly to the even function in part A, if you look at the exponents of g of x, we have x to the third power, and that number is odd. And over here we have an x to the first power. It's not written usually, but I'll put it in here for illustrative purposes. We have a third power, that's odd, a first power, also odd. So this whole entire function is odd. As a quick warning, you cannot have any constants being added or subtracted to an odd function and have it still be odd. Now part C, h of x equals 2x minus 3. Again, per suggestion, the first function I would like to check is h of negative x. And so again, simply substitute negative x into the function, simplify it down, get negative 2x minus 3. And these are not the same. So h of x is not even. Alright, so the next thing we need to check is negative h of x. And maybe when we find negative h of x, it equals what we found up here earlier for h of negative x. Let's check it out. So again, I'm going to negate the entire function, 2x minus 3. Then we can distribute this negative as a negative 1 to get negative 2x plus 3. And it turns out this and this, they are not the same either. So what does that tell us? H of x is not odd. So our conclusion here is if h of x is not even and h of x is not odd, then h of x is neither.